Welcome back to the deep dive. Today, we're going to unpack something pretty innovative, maybe even a bit mind-bending: rain-powered solar panels. Our mission here is to figure out how this tech actually works, what its potential is, and what hurdles it might face, especially thinking about a place like Louisville, Kentucky. I mean, getting power from raindrops, it sounds almost like something out of a sci-fi novel.
It really does, doesn't it?
Yeah.
But it's a fascinating step forward. So the core idea uses these things called Tribo electric nanogenerators, or TENG for short. Think of them as tiny generators that convert the kinetic energy, the motion of raindrops hitting the panel, into electricity.
Yeah.
And what's really revolutionary, is that it addresses that big weakness of normal solar panels.
Ah, right, the fact they don't work so well when it's cloudy or raining.
Exactly. With TENG, you get dual sources: sunlight when it's clear, obviously, but also energy from raindrops during bad weather or even at night if it happens to be raining. So instead of rain being a problem, every single drop becomes a tiny power source. It really unlocks more consistent energy harvesting.
That's wow. Okay, but let's be practical for a second. Can the energy from just, raindrops actually add up to something significant? We're not talking about a huge force here. How does that scale up? And specifically for Louisville, you mentioned Louisville, how does its climate play into this?
That's a fair point. And actually, Louisville's climate is what makes it such an interesting case study, maybe even an ideal one.
Hmm.
See, the city gets around 44 inches of rain per year on average. That's quite a bit of opportunity. And you also have about, 168 cloudy days annually?
Yeah, that sounds about right. Lots of gray days.
Right. So these panels could really help bridge that gap between sunny day production and those overcast periods. Louisville's drizzle suddenly becomes, well, an energy asset. It's almost like the weather pattern there is tailor-made for this kind of dual approach, yet more reliable power output overall.
Okay, that potential for consistency is definitely appealing. But as always with new tech, what about the cost? Is this going to be prohibitively expensive compared to standard solar?
Cost is always the big question, isn't it? Let's look at the numbers. A typical 5 kilowatt traditional solar system costs roughly $14,000. That drops to maybe $9,800 or so after the federal tax credit. Now, for these rain-powered systems, the estimates right now are closer to $17,000 upfront.
Okay, so a bit higher.
Yeah, about $11,900 after that same tax credit, so maybe 20% more to start. But here's the interesting part, looking long-term. Traditional solar might save you, say, $21,000 over 25 years. Some early projections suggest these rain-powered systems, because they generate more consistently, could potentially double those savings over the same period.
Double. Wow.
Yeah, that higher initial investment might actually lead to a much greater return over the lifespan of the panels.
That's a significant potential upside. Are there any programs already happening in Louisville where this kind of tech could, potentially fit in?
Absolutely. Louisville has its Solarized Louisville program, which has been pretty successful. They've helped install over 150 traditional systems already. Rain-powered panels could be a fantastic addition to programs like that. They'd boost the energy output during those frequent rainy spells. And importantly, they could reduce the need for quite as much expensive battery storage to cover cloudy days.
Ah, okay, that makes sense. Less reliance on batteries.
Right. And this all feeds directly into Louisville's goal of hitting 100% clean energy by 2040. Plus, you have those potential long-term economic benefits for homeowners we just talked about.
So, yeah, the benefits seem pretty clear, aligns with sustainability goals, potential for better long-term savings. But what are the catches? There's got to be some hurdles.
Oh, definitely. We need to be realistic. This technology is still fundamentally experimental. It needs a lot more testing before it's ready for mass adoption. That's the big one. Also, think about maintenance. TNs involve friction and impact. Those components might wear out faster or need more checks than standard static solar cells. So maintenance costs could be higher. We don't fully know yet.
Durability concerns.
Exactly. And speaking of durability, these panels have to be tough enough for Louisville's weather. We're talking wind gusts, sometimes up to like 104 miles per hour. That's serious force.
Wow, yeah. Hurricane level winds almost.
Precisely. So building panels that can generate power from rain and withstand that kind of punishment is a major engineering challenge. Long-term viability really depends on that robustness.
Okay, so wrapping this up for you, our listener, and for Louisville specifically. Rain-powered solar panels are definitely a promising development. They seem to fit well with the city's climate, support its green energy goals. But yeah, there are still those higher upfront costs and some technical questions to iron out.
I think what this deep dive really shows is how innovation can flip perceived weaknesses into strengths. Taking something like rain, which limits traditional solar, and turning it into another energy source. So Here's a thought to leave you with. What if the next big step in clean energy isn't just about getting more power from the sun, but about making every kind of weather condition a chance to generate power? Imagine how fundamentally that could change our approach to energy. Truly reliable, clean power no matter what the sky looks like. That's a pretty exciting possibility.